Hello friends, today we're doing probability. So first we have independent events. And so two events are independent if the occurrence of one event has no effect on the probability of the other event. I feel like I used weather in the last notes as an example, but it's basically, whatever the probability of raining today, it has nothing to do with if it rained yesterday. And so, and probabilities with independent events. So the probability that something and something else occurred, the probability of A and B equals the probability of A times the probability of B. So if we look at this spinner over here on the right, if the spinner is spun twice, we'll find the probability that it will land on green, then red. So essentially the probability of green, then red is going to be the probability of green times the probability of red, because you're spinning the spinner every single time is independent of the last. So the probability of green, looks like there's 6 spaces total, or wedges or slices of pizza or whatever you want to think about it as. And so we have 2 green, so 2 out of 6 are green. For red, 3 out of 6 are red. And you can multiply from here. 2 times 3 is 6. 6 times 6 is 36. And this simplifies to 1/6 probability that you'll spin green and then red. And keep in mind in this case the order doesn't matter. Red then green would be the same as green then red. Probability of yellow then green will be the probability of yellow times the probability of green. There's 1 yellow out of 6. Green was 2 out of 6. 1 times 2 is 2. 6 times 6 is 36. So the probability is 1 out of 18. Yellow then yellow is just the probability of yellow times the probability of yellow again. Yellow was 1/6. Probability of yellow is 1/6. 1 times 1 is 1. 6 times 6 is 36. And you can't simplify that. What's the probability of a family having 5 girls in a row? This one's funny, and it reminds me of when I was having my second kid. All of my students said, well, you'll probably have a boy because you already had a girl. But really, these are all independent events. So 5 girls in a row would just be the probability of a girl multiplied by itself 5 times. So the first time, probability of girl, 1 out of 2. And we're talking about, gender identity or gender at birth, right? So there's girls versus boys in terms of at birth. So 1/2, and then second girl will be 1/2. Third girl is 1/2. Fourth girl is 1/2. Fifth girl is 1/2. So we get 1 out of 32. So those are independent events where they're unaffected by the events that occur before or after them. Dependent events. This is where the occurrence of one event affects, so this does affect the probability of the other event. So now we have and probabilities with dependent events, I suppose we could pronounce it. So the probability of A and B, and so the formula doesn't look much different, but how we do this changes. So we get the probability of A times the probability of B given that A has occurred. So So let's do examples. This will make that make a little more sense. So we have a box of 20 chocolates. We have 5 chocolate-covered cherries. What's the probability of selecting 2 chocolate-covered cherries in a row? So the difference here is you are going to eat a piece of chocolate and you're not going to put it back, right? So you're not replacing it. So this will be the probability of the first chocolate-covered cherry. Well, there's 5 of them. So 5 out of 20 that your first one is a chocolate-covered cherry. Now the second one, you ate one. So now there's only 4 chocolate-covered cherries and there's 19 total. Okay, because in both cases there were 20, you ate one, now there's 19. There were 5 chocolate-covered cherries, you ate one, now there's 4. 5 times 4 is 20. 20 times 19 is 380. If you simplify this, you get 2 over 38, or 1 out of 19. Okay, you want a free trip to France for you and 2 friends, and you have 10 friends who want to go, so you can invite 2 people. You have 10 friends who want to go. 3 of your friends speak French. If you randomly select 2 of your friends, what's the probability that you select 2 friends who speak French? Wow, this is confusing sounding, which I put in here on purpose because sometimes problems sound very confusing, right? So 2 friends. So the probability of your first friend speaking French. Well, we have 3 out of 10 who speak French. That'll be 3/10. Now, when you go to select your second friend, you already selected one. You can't select them again. So now we have 9 left. If the second friend also speaks French, now there's 2. So first one, there were 3 out of 10 who spoke French. You chose one of them. So now there's 2 total who speak French that are left, but there's only 9. So 3 times 2 is 6, 10 times 9 is 90. So this is 1 out of 15. You are dealt 2 cards from a 52-card deck. What's the probability of getting 2 kings? So probability of the first king, well, there's 4 out of 52 in a deck. For the second king, well, you chose a king, right? So how many are left? 3. You had 52 cards and you chose one, so now there's only 51. So we get 12 out of 2,652, which simplifies. Again, please use your calculator, easy enough to simplify, 1 over 221. So conditional probability is essentially what we were doing. It's the and probabilities with dependent events. This is how it's often written, but not always. Probability of B given A, so that vertical line means given, is equal to the conditional probability of B. So essentially this is the second part of this formula that we did up here. So we're really looking at this probability of B given that A has occurred. So if you select a letter from the letters of the English alphabet, so R's, find the probability of selecting a vowel, given that the outcome is a letter that precedes H. Okay, so what I would recommend whenever you see the word given, just underline that sort of phrase, because that's always going to determine our denominator. So the given determines denominator. Kind of run out of space. I'm just going to write it down here. Sorry about that. And so the outcome being a letter that precedes H, that'll be our denominator. Well, how many letters precede H? A, B, C, D, E, F, G. So 7. How many of those are vowels? A and E. So our probability is 2 out of 7. So we were finding the probability of selecting a vowel given that the outcome is a letter that precedes H. So again, our given determines, it kind of narrows down what we're looking at so that we have just the letters that precede H, and then we were choosing the vowels from there. Now we'll use the table. So if a person is randomly selected from the table, what is the probability that the person is female given that this person is divorced. So that's telling us our denominator. So our denominator is going to be divorced people. Sorry, I didn't really talk about the table. It's marital status of the US population, ages 18 or older, and millions. Not sure what year, it's from the textbook, so it might be early 2000s, but still data for us to look at. So given that this person is divorced, total divorced, 21.7. Numerator, female. So out of that 21.7, because we already narrowed it down, so we're only looking at this column right now, female was 12.7. And then from here, we can just divide, because this isn't really simplifiable. We have decimals and fractions, which is kind of iffy anyway. So if you divide this, you get 0.585, or about 59%. Next one, probability that the person is widowed, given that this person is a man. So men is going to be our total. So our total is 102.4. So now we're looking here. I'll switch colors to make it maybe clearer, hopefully. So our total is 102.4. Our numerator is widowed. Out of this row, we just narrowed our view down to, I suppose. That's all we're looking at. And so widowed was 2.7. So we have 2.7 divided by 102.4, which is 0.0264, or about 3%. Next one, probability that the person has never been married. So here, easy to overthink, but try not to, because there's really no given in there. We're really just looking probability has never been married. So we're going out of the total, how many have never been married? 51.9 out of 212.5. Oops, I'm just adding lots of decimal points today, apparently. 212.5. This equals 0.244, or about 24%. Probability that the person is female or divorced. This is like the last lesson, right? Maybe? So female or divorced means we can do the probability of female plus the probability that the person's divorced minus the probability of both, or female and divorced. So probability of female, and we're really looking at the ultimate total. So 212.5 is our denominator for all of these. Female was 110.1 out of 212.5, plus divorced, which was 21.7 out of 212.5, minus both, so female and divorced was right here, 12.7 out of 212.5. And so if you add 110.1 plus 21.7 minus 12.7, you get 119.1 over 212.5. If you divide those, you get 0.560, or about 56%.